Hello and welcome to Pytechie. Today we are diving into percentiles and quartiles. Percentile. Ever wonder what they really mean? They are a simple yet powerful way to understand how one value stack up against a whole data set. Think of it as a dividing the data into 100 equal parts. For example, in education, your percentile tell you how will you perform compared to others. If you are in a 80th percentile, it means you score better than 80% of students. That's the top notch. Same applies for the in other area also. Suppose if a web page load in a 95th percentile, then 95% of page load faster and 5% are slower. A quick page is a key of keeping user happy. So these are the few real-time example how we can compare the percentile with the whole data set. When calculating a percentile, sometimes the position land cleanly right on a whole number. In that case, simple just grab the value at that rank in your sorted data sets. No math magic needed. What if it's decimal? That's where interpolation come in. It's a method used to estimate a value between two known data points, perfect for whose percentile position that don't line up exactly. This approach helps refining results, especially when working with the smaller data sets. So, this is a formula to calculate a percentile. So, here we have a p divided by 100 into n plus 1, where t is a desired percentile and is a number of values in data set. So we can use interpolation if the position is not a integer value. So if it is a floating point value or a decimal value, we can use a interpolation formula. So here is a interpolation formula p equal to lower value plus d into upper value minus lower value. So d is a decimal part of position. Suppose, for example, the value is position value is 7.7, then we consider d equal to 0.7 after a decimal value, which is a zero point 0.7. Lower value, a value at the floor of the position, and upper value is a cell of the position. Let's talk about percentiles and percentile rank, two sides of same statistical coin, but not quite same. Percentile rank tells you the percentage of values in a data set that fall below a specific value. So instead of asking what's value is the at the 80th percentile, we ask what percentile rank does this value have. A percentile is a value below which a certain percentage of data falls. Meanwhile, percentile rank is the percentage of values that are less than or equal to a given score. If a percentiles tell you where a score sits, so percentile rank tell you how many people you have outscored. One starts with a percentage, the other end with the same field very differently. This is a percentile rank formula. So here we have a number of value less than x divided by total values in dataset into 100. Quartiles. Quartiles are essentially a percentiles with a new outfit. They divide data into a 4 equal parts, helping you see where values tends to bunch up or spread out. Here is a breakdown. Q1 is a 25th percentile, meaning one quarter of your data fall below this point. Q2 is a median, the 50th percentile, right smack in the middle. And Q3, that's the 75th percentile, where three quarters of your data lie below. With these three make markers, you have got a powerful snapshot of your data distribution. Quartile quietly work behind the scenes. telling a big story by slicing data into four parts. So these are the formula to calculate a quartile Q1, Q2, Q3. So in Q1, we'll take a value at position 1 fourth into n plus 1. Similar with the Q2, we'll take a position 1.5, and then in Q3 position, we'll take a 3 divided by 4, where n is the size of data set. Now let's see a very simple example how we can calculate percentile, percentile rank, and quartile. Here we have a sample data set. First we will sort this data set. After sorting the data set, we can calculate percentile. Here we are finding a 25th percentile. So as per the formula, we have a position equal to p divided by 100 into n plus 1, where p is a percentile, which is a 25, and n is a number of datasets. So total we have a 8 dataset. So here is a 8. So then we'll divide 25 by 100, which is 0.25 into 8 plus 1 is 9. And then we multiply 0.25 into 9, which is a 2.25. Now we got the decimal value, so we can calculate a interpolation between second and third point. The value is 2.5. Because of that, we are calculating a second and third point. So second point is a 20 and third point is a 30. So as per the interpolation formula, lower value plus d into upper value minus lower value. So lower value is a 20 plus d is a decimal point value, which is 0.25 into upper value 30 minus 20. So after the calculating all this, we get the 22.5 is a percentile 25th position. Now let's calculate a percentile rank. So here we are finding the percentile rank of 60. So first we will select all the element which is lie below the 60. So there are total 6 element including a 60. So percentile rank formula is number of values less than to the rank divided by number of values in dataset into 100. So total 6 element which is lie below 60 divided by 8 total element into 100, which is a 75 percentage. Now let's calculate quartiles. Similarly, here we will take as per the formula 1 divided by 4 into n plus 1. N is a number of dataset. So total dataset is a 8. So 0.25 into 9 is nothing but a 2.25. Again, it's a decimal value, so we'll calibrate the interpolation. Similar formula, we got the Q1 is a 22.5. Similarly, we can calculate a Q2, Q3. So this is a very simple formula and a very simple example to calculate a percentile, percentile rank, and quartiles. I hope you understand the percentile and percentile rank and quartiles. We'll see you in next one. Thanks for watching.